All right, so let's take a look at this example here using sine law. Again, we're given a set of numbers. We're given a set of dimensions. We're going to call this A. We're going to call this one here C, and we're going to call this one here B. That means that this is little b. Again, first thing that's always important is we label. Again, the labeling doesn't have to be exact like this, A, B, and C. It specifically just has to have 3 letters to it. You're usually going to have A, B, and C maybe are the easiest to see because I often use them. They're often used as kind of a benchmark type thing that we would look at, but you can use any letters at all. Okay, so A, B, C, our sides are across from our angles. Now, sine law, when we type it out, looks like this here. Sine A over little a is equal to sine B over little b, which is equal to sine C over little c. Okay. Here we have big A, little b. We want to try to find big B. We can use the first little part of sine law. So when we put this in here, we're going to notice something very unique here, or I should say something that is very alarming. I should use the word alarming actually, and that's equal to sine B over little b, which is 38. Okay. We should know something that's very alarming. Okay. Number one, okay, this here is definitely an obtuse angle. Okay. When we solve for this, okay, and so I'm gonna put in the answer. So it's angle B is equal to, so we're gonna solve cross multiply and divide. Use our calculator. 38 times sine of 30, I gotta close brackets, divided by 20, yep. Okay, inverse sine of the answer equals 71.8 degrees, or we're gonna call it 72 degrees. Okay, or at least here I should say that this is 72 degrees. Okay, something that you should notice right off the bat, and I realize that we often tell you don't look at the diagram because it's not necessarily going to be accurate. Well, diagrams will at least have somewhat accuracy to it. You're not going to have a huge angle like this, which is definitely obtuse. It's definitely more than 90 degrees. You're not going to have a huge one like this and then get an answer of 72. Okay, it might be really close. Like we might say, like, you know, it might look like could be obtuse, could be, you know, could be like in the 85 to 95 range, and then maybe we're unsure. But in this case here, you definitely know. And on a test, if I give you a question like this, you're going to definitely know if it is if it's an obtuse or an acute angle. 72 is an acute angle. So there's 2 things to look at. Number one, either you made a mistake or I made a mistake in this case here in calculating angle B. Number 2, I know I didn't because I've gotten this a number of times here. At 72 degrees is not this angle here. 72 degrees, I'm just going to pull out my drawing tool here, is if I'm going to extend this here, this angle here is 72 degrees. Okay, the supplementary angle to theta is 72 degrees. So in this case here, we have to subtract it from 180. So to get theta, and this is, again, very important, this is not actually angle B. This is the supplement to angle B. And I'm gonna put this over here. I'm gonna quickly put in got all sorts of stuff happening here. Angle B, there we go. Get rid of the rest of it here. So angle B is equal to not 72 degrees, but 180 degrees minus 72 degrees. And so angle B is equal to 108 degrees. Okay, it's most definitely an obtuse angle. Okay, very important that we see that it's most definitely an obtuse angle. So we have to understand that that this, what we're given is going to be the supplement to our angle. Okay, so you're going to notice that when trying to find an obtuse angle, sine law always gives us the supplement angle, a supplementary angle, and that's the angle outside the triangle. We have to use that knowledge to understand that we need to subtract that angle that we're given from 180. Okay, and so in this case here, this is in fact not true. Okay, this one's not true. This is the supplement. Okay, so this is the supplement angle. Okay, the supplementary angle. It's a supplement angle. It's the angle, plus that we're given to find 180. Now, that is using those things there. Let's take a look at if we have an obtuse triangle and we need to use cosine law. Cosine, the way that cosine works, it actually is going to give us an obtuse angle. So in this case here, where we're given x, y, z, okay, so this here is going to be little x, this one's going to be little y, and this one here is going to be little z. There you go. Okay, and we're going to use our cosine law. Okay, I'm going to use the abbreviated cosine law. I'm going to be trying to find angle y. So we're going to have, in brackets, y squared minus z squared minus x squared, close brackets, and we divide that by, in brackets, 2 times z times x, and that equals to cos of y. That's that equals to cos y. When we plug all that information in, and we have a whole lot, I'm not going to use units as it gets really big. I'm just going to use the numbers right now. Normally, I would push for units. If I was writing this out on paper, I'd have units. This program here doesn't give very good, or it really extends things, so I'm not going to put in units right now. But we would have, let's see, this would be 14 squared minus 6 squared minus 10 squared divided by negative 2 times 6 times 10. And that is going to equal to cos of y. Again, we have to do inverse cos as well to get our answer. But angle y, in this case here, you'll notice, okay, and now very specifically, angle y is definitely an obtuse angle. So it's definitely more than 90 degrees. So we should get an angle more than 90 degrees. And so what we're going to have here is we're going to have 14 squared minus 6 squared minus 10 squared. And I'm going to redo that all again because I want to do brackets. 14 squared, 6 minus 6 squared minus 10 squared divided by, notice the brackets, negative 2 times 6 times 10, not minus, times 10. We're going to be given some sort of decimal. Okay, it's always going to be a decimal. In this case here, it's a negative. We're in degrees, inverse cos of our answer, and we get 120 degrees. So y is 120 degrees. You will notice that with cosine law, it already gives you that obtuse angle, and we don't have to solve for it. But if we are given something with sine law and we need to find that angle using sine law, we're going to be given this supplement angle. We're not going to be given the actual angle. Okay, so very important that we understand that. Very important that we recognize what we're doing there, and that we have to do a supplement to solve that.